Our next section deals with zeros and applications of linear functions. You're going to like the zeros part so much. You might not be so thrilled with the applications. Alright, so examples. Determine the zero of f of x equals 2/3 x minus 8. Alright, determine the zero is another terminology for simply find the x-intercept. So finding the zero, it's called the zero because instead of writing f of x, we write 0. So really, this is just asking you to solve the equation 2/3 x minus 8 equals 0. So that's why I say I think you're going to like the determine the zeros part. Pretty straightforward. 2/3 x equals 8. Multiply both sides by 3/2 to clear that fraction. We get x is, let's see, 4 and 1, x is 12. Okay? So that's all there is to that. Determining the zeros means set it equal to 0 and solve. It's the same as finding the x-intercepts. The second part deals with applications. Applications is a nice way of saying word problem. So let me find a word problem here. Okay, here's one. A slice of carrot cake from a popular restaurant, the Cheesecake Factory, contains 1,560 calories. This is 3/4 of the average daily calorie requirement for many adults. Find the average daily calorie requirements for adults. Alright, so the place to begin with a word problem usually is at the end. Usually, the last sentence will tell you what you're looking for. Find the average daily calorie requirement. So, that's our variable. We're going to call that x. X equals, I'm going to abbreviate here, average daily calorie requirement, because I'm a little lazy here, a little cramped for space. I didn't want to write that all out. Alright, so there's x. Once we have x, we have to come up with an equation. And the equation, in many cases, actually comes from the sentence before. So, this is. Well, what does this refer to? This refers to that number back there. So this, 1560 calories, is equals 3/4 of. Of is a word in math that means multiply. So 3/4 of the average daily calorie requirement. The average daily calorie requirement we called x. So, here's a little check as to, is my equation a good equation? Look at your units. Over on the left-hand side of our equation, we have calories. What are the units on the right-hand side? Well, x is average daily calorie requirements. So x, the units on x, is also calories. We have calories on the left, we have calories on the right. We can be pretty sure we have a valid equation. Alright, once you get the equation, people usually don't have a big problem. To get this equation, it's pretty easy. Solve this equation, I mean. I'm just going to write it down without the units in there to clean it up a little bit. To solve this equation, it's very similar to the last problem we did. We have to get rid of the fractions. So we multiply both sides by 4/3. We grab our calculator. X is, my calculator gives me 2080. And the units would be calories. Alright, let me find another one here. Okay, so here's a problem I like. City Cab charges $1.75 pickup fee and $1.50 per mile traveled. Diego's fare for a cross-town cab ride is $19.75. How far did he travel in the car? Okay, so this is a fairly common problem that we see in some business classes that we teach here at the college. basically we have something that's called a fixed cost, which is this here, $1.75 pickup. It costs you $1.75 just to get in the cab. That's called a fixed cost. And then we have something called a variable cost. It costs you $1.50 per mile traveled. Okay. And then we have this, $19.75. That would be total cost. What's his total fare? All right, but what are we looking for? Well, once again, what are we looking for almost always comes from the very last sentence of the word problem. How far did he travel? So x equals distance. And what are the units on that? Distance here is in miles because I see $1.50 per mile earlier in the problem. So x is distance in miles. All right. So let's see. I've got his total cost. So there's the total cost. So that's the total. So 1975 must equal something. If that's the total cost, it must be how much he spent altogether. So how much did he spend? He spent $1.75 just to be picked up. So $1.75. That's what it costs just to sit in the cab. Plus $1.50 per mile. So I'm going to write that number down. Alright, but now let's think about what our units are here. 1975, that's money. $1.75, that's money. But what's this $1.50? This $1.50 is money per mile. Per is a word for division. Okay? So right now, my equation doesn't make any sense because on the left-hand side, the only units I have are dollars. On the right-hand side, I have dollars, and then I have plus dollars per mile. I can't add dollars with dollars per mile. Those don't work. So what we need to do there is I need to multiply by x miles. And then notice what happens. With my units, I have miles on top and miles on bottom. They cancel out. So notice what I have now. My only units, I have money on the left, and then on the right-hand side, I have money plus money. This equation makes sense. Alright, so let me just rewrite the equation down without the units, and then we'll solve it. Alright, so I subtract $1.75 on both sides. I get 18 equals 1.5x. X is 18 divided by 1.5. Once again, I like my calculator here. 12 miles. Okay, so I have a lot of students always ask me, do I have to write down the units? Do I have to write x equals distance in miles? And my answer is yes. As you can see, I think units are very, very important. To me, units are really the key way that you figure out your equation, figure out if your equation is valid or not. So when you go to do a word problem, I absolutely positively expect you to declare what your variable is. I will absolutely require that on a test. And then I expect you to write your equation, and I won't require you to write your units down, but I highly recommend it because by looking at your units, you can tell if you're right or you're wrong. Alright, let me load up another word problem here. Alright, this is a very typical type problem people think of when they think of math word problems. A private airplane leaves Midway Airport and flies due east at a speed of 180 kilometers per hour. 2 hours later, a jet leaves Midway and flies due east at a speed of 900 kilometers per hour. How far from the airport will the jet overtake the private plane? Alright, once again, I read my last sentence and I know what I'm looking for. How far from the airport? So x equals distance in, my units this time are kilometers because I see kilometers per hour, kilometers per hour. Distance in kilometers. Okay, now what we're going to use this time, very famous formula, distance equals rate times time. Alright, so what we need to do here is, let's look at the distance of the two planes. So, let's start with the private jet. So, private jet. Distance equals rate times time. So, do we know the distance? No, I don't think we know the distance, right? We called that x. So that's x. And make my symbol there. X equals rate. I know its rate. Its rate is 180 kilometers per hour. Kilometers per hour times the time. I don't know its time either. So this is kind of a weird word problem so far. It's got two variables. But notice time is in hours. So my units cancel out. And I have distance on the left, x kilometers, equals 180 kilometers times time. My time units cancel out, so I have kilometers equals kilometers. Alright, so far, not great, because I have an equation, but my equation has two letters in it. Not very good at solving equations with two letters, so let's take a look at the jet, see what the jet did. The jet, I still have distance equals rate times time. So for the jet, the distance, well, I want the jet to catch the private plane. What that means is the jet and the private plane have flown exactly the same distance. I'm still going to have x kilometers equals, his speed is 900 kilometers per hour. But what's his time? What a lot of people would be tempted to do here is put t for time. But that's not quite right. What it needs to be is t minus 2 hours. Why t minus 2? Because 2 hours later. The jet hasn't been in the air as long as the private airplane. The private airplane left first. So, we have to have a little t minus 2 there to take care of that. Alright, but now look what we have. I have x in this equation, and I have x in that equation. X is exactly the same. The equation I need to solve to answer this is 180t equals 900 times t minus 2. Alright, I'm running out of space on this page, so I'm going to clear some things out. But we need to remember that equation, 180t equals 900t minus 2. So I'll leave the word problem there. 180t equals 900 times t minus 2. Solve this equation. 180t is 900t minus 1800. Subtract 900t on both sides. Negative 720t equals negative 1800. So t is negative 1800 divided by 720. I get 2.5 hours. Alright, there we go. Whoops, be careful. And this is where a lot of people will make a mistake, and again, this is where it's important. X equals distance in kilometers. Remember what we were looking for in this problem? How far. We didn't find how far, we found how long. It's going to take the airplane 2.5 hours. It's going to take the jet 2.5 hours to catch up. Actually, it's going to take the jet a half an hour, because the jet left 2 hours later. T minus 2 would be a half. But we really want the distance. So what I need to do is I need to take this number, and I can plug it in there, or I can plug it in there. Both of those give me the distance. So the correct answer 180 times 2.5 is, again, I grab my calculator here, 450 kilometers. Alright, so there's another good example of why it's important to write this down at the beginning. It's important to write down what you're looking for, so that when you get done and you get an answer like this, you know, well, that's something important, but I'm not done. I got more work to do. Alright, one more word problem and we'll be all done. Dimitri's 2 student loans total $9,000. One loan is at 5% simple interest and the other is at 6% simple interest. At the end of 1 year, Dimitri owes $492 in interest. What is the amount of each loan? Alright, this one's a little different. What is the amount of each loan? So we're looking for two things in this problem. Alright, so I'm going to let X equal money at 5% interest. Okay? But we also need to find the money at 6% interest. I just took the iPad there. 6 at, oops. Start all over here. Money at 6% interest. Now, a real common mistake I'll see is people call that X also. Can't be the same. It doesn't tell me that I invested. It doesn't tell me that I've borrowed the same in both accounts. All right, so here's what you got to look for here. Dimitri's student loans total $9,000. So he owes $9,000 altogether, but X of it is already used up back here. So how much is left? Well, if you have 9,000 out and X of it is in one account, then 9,000 minus X must be in the other account. Alright, so there's your two things that you're looking for. You're looking for X, the amount at one account, and 9,000 minus X has to be the amount in the other account. Alright, now interest. So if I borrow some money at 5% interest, then the amount of money I owe is 5% times the amount of money I borrowed. So there's the interest on the first account. I'm not going to write my units down. Those units are interest. Plus, here's my interest on the second account. The second account I'm paying 6%, and I borrowed 9,000 minus X. So there's my interest on the second account. Interest plus interest equals interest. In this case, my interest is $492. Alright, so we solve 0.05x plus 0.06 times 9,000. Grab my calculator there. Should be 540, I think. Yep. Minus 0.06x equals 492. Combine my like terms, 0.05x minus 0.06x is minus 0.01x plus 540 equals 492. Subtract on both sides, minus 0.01x is 492 minus 540 minus 48. Divide by 0.01, x is 4,800. So 9,000 minus x is 4,200. Alright, so there are examples of the classic word problems you're going to see. I'm not going to kid you. I'm not going to tell you word problems are easy. But I really think the key to word problems is reading carefully, starting at the last line. The last line in every problem I did told you what you were looking for, and then keeping track of your units. If you can start with the last sentence and write down your units as you go, you will usually come up with the correct equation.